Hello everyone. The applications for EEG data of the brain study by matrix variate logistic regression method has been studied by two scholars. One is Dr. Hong from Institute of Epidemiology and Preventive Medicine in National Taiwan University, and the other one is from Dr. Huang from the Institute of Statistical Science in Academia Sinica. The motivations of the paper is from studying of the electroencephalograph dataset between the genetic predisposition and alcoholism groups. Previously, they only have the samples of 122, and when y equals to 1, the variables of setup representing for the alcoholic groups, and for the 0, it representing the control groups. And also, on the other hand, the given matrix also has a matrix 256 times 64, which is a matrix covariant. And that covariant matrix representing the corresponding image of the ith patient. But however, there are so many parameters, but we only have samples 122. So that comes from the low-ranking reduction problem from the matrix. The main idea comes from that. It simply stack the covariate matrix as a vector and fit the conventional logistic regression model. Relevant information can be lost. And besides, it probably is not very efficient. Let's see the original traditional conventional logistic regression model. It depends on the logistic regression models of the probability when the y equals to 1, that means the alcoholic groups. Conditioning on x, which is equals to a formula gamma plus sigma, summing for all I and j row and column of the constant variable times the entries of the matrix. And if we just expand this sigma formula as the vectors, multiplications of vectors, at least from this doubling indexes summation, you can see that we have to take here every column and every row together. That means as long as there's a slight difference, and also as long as the number of samples is not very large, then the bias could be, and also the calculation efficiency might be very hard. So what is the solutions that I have proposed? They're trying to propose the solution which is called a matrix variate, a new logistic regression model. Instead of that, their logistic regression formula is by this formula, gamma plus alpha transpose times x times beta, where the x is the original covariant matrix previously that we have studied from the last slide. But this time, they're trying to fix the parameters with a constant that is alpha to the transpose times x times beta, where the first parameter gamma is a random variable that might represent it as a noise on the normal distribution, and the alpha and beta are row and column parameter vectors, but that's fixed one. And especially in particular, they're trying to estimate the covariate specific odds ratio for that, where if you check this log of Rij, which is equals to alpha I times beta j, where the alpha I and the beta j are those parameters that we can see from the last slides with indexed. and where alpha means the defect of a different time points, and the beta shows the defect of different channels. By their reasons for adopting this new model is reasonable to assume that the most covariants have effect size near zero in modern biomedical research, and should be a low-rank matrix. But for taking log and also the multiplication is some general uh, mathematical methods for that has been used for. So this is the tricky part. Once they determine the fixed numbers of alpha and beta and take the log of it, you can use this maximum likely loghood functions combined with the Newton methods with the regularization. The formula 6 is a penalty function, penalize the log likelihood functions. L of theta is the summing for all index from 1 to n of yi of this one with the log likelihood. And we're trying to maximize the iterative results that has been shown in Formula 8. And that happens to be the Newton method with regularization. The last step of this statistical discovery journey is using the Hessian matrix. So this is the Hessian matrix of L lambda of theta that derived for the optimization procedure. And after that, we can use the Hessian matrix, some basic calculus, second differentiable calculus technologies for decompose the structure of it. But I mean, in this part, we could not see sort of what is the symmetric of beauty of it, but we know that this happens from some normal statistic method. But even before that, because we have determined the alpha I and the beta j that fix the constant of it. So the technique they have used before that, there are some pre-processing steps. The pre-processing steps first is they use the extensions of a principal component analysis. That is called a generalized low-rank approximation, and they have tested that how many constant numbers of P and Q that could be used for simplifying the original given covariant matrix. They have tried 2020, 3030, and 1550, and so on. Once they reduce the parameters by this generalized low-ranking approximation to 1515, then they applied some standardized procedures for standardizing that given reduced matrix, then apply this the major contributions of them, the matrix Variate Logistic Regression in their third steps. But then we want to introduce you the way that they do for the estimations of that. They do exist estimates of alpha I and estimates of beta j, where you can see that it's less than 0.5 of the estimations of that, but the specific meanings of that we cannot tell you because this is just uh, some parameters that has been given for this. But it's less than 40%, at least for the alpha I, and also for the beta j also is around between the positive and negative. No, not 40%. Sorry, it's between the positive 0.3 and negative 0.3 for the alpha I, but for the beta j it's between 0.4 and minus 0.4. And even for controlling this estimation, some interesting probability and the predicted probability of the alpha and beta. After we observe that, I think the authors trying to show us when they approach that, what would be the predicted probability. On the left-hand side of the figure is the estimations of that between the subject and the probability. We can see that under the control group, the predicted probability of the subjects is less comparing to the predicted probabilities of the alcoholic groups. And what is that? Uh, it probably because they're, in general speaking, I think they're trying to explain that the brainwave of some alcoholic groups is has specialized patterns in that brainwave, but for the control groups, it's hard. You can also see that from the right hand side of the subfigure, which is called the kernel density estimates. It's similar to CDF, and but its conversion rate has been claimed to be faster than the comparing to the normal distribution representation. And you can see that also the distribution although it's not symmetric based on 0 because of the alpha I and beta j, they might have some shifted, but the distribution, the symmetric points of the distribution of these alcoholic groups is relatively denser than the control groups. And how do they determine the parameters? The tuning parameters for different logistic regression models are determined from an independent simulation by maximizing the classification accuracy, and the simulation results are reported with the 1000 replicates. So for this part, what we can infer, I think these authors, they have a series of papers, and they're trying to say that their contribution is based on the extensions of the principal component analysis, especially from 2-dimensional to 3-dimensional, and they have applied from other samples except for this electroencephalogy. And what can we infer from this? We know that from UC Berkeley, they do have some project which is called SETI, searching for ET, extraterrestrial, and also they have actually observed the telescope and also the receiving. They're trying to observe the sky, the star sky, by telescopes, and they also recently reactivated the project because after 10 years of their study, uh, they could not find very interesting results, except if you recently noticed some opinion or new study from one guy which is called like beta astronomist. If you found his twittering his Twitter, they trying to find some interesting results by redigging, uh, remining all those efforts. Uh, Especially they used some simple high school technology that we have studied from the physics, which is called the Doppler effect, for reminding the observation for the observation data. And they do believe that their new discover of the 10 years data that has been released from the NASA websites, they have a new results. But can we do better? Just about this. I guess there do exist some interesting connections between the new method that has been applied for the human body instead of that, but just study for the intergalactic body. So if you're interested in the project that we study, please contact us, Algorithmic Research Incorporation. And thanks for listening to this video. Bye bye.